Beta receptors, we're going to put that on the other side. That's why we put this in the middle, because I got to put stuff on this side too. All right? So, you're going to have a neuron come out of the thoracic region. Short preganglionic, long postganglionic, and we're going to have the heart. Beta 1 receptors. As soon as you hear beta 1 receptor, you think heart. All right? So when norepinephrine is released onto these beta 1 receptors, what's going to happen is we're going to excite the heart. You're going to make the heart beat faster. You're going to make the heart beat harder. Your sympathetic nervous system stimulates your heart. Okay? And that should make sense given what the sympathetic nervous system is for. Fight or flight, physical activity, correct? Okay? So, that's the heart. Now we're going to have the beta 2 receptors. The beta 2 receptors are inhibitory. Beta 1s are excitatory, beta 2s are inhibitory. We're going to make a tube. This tube is not a blood vessel. This tube is not your digestive tract. This tube is an airway. These are the tubes that allow air to go in and out of your lungs. The smooth muscle cells have beta 2 receptors on them. Beta 2 receptors are inhibitory. Beta 1s excite, beta 2s inhibit. And so, when we excited these tubes over here, they constricted. If we relax the tube, if we relax any tube, we're going to cause it to dilate. What do I have in the nose? What's the word I use in the nose? I use relax, so I use the same word. We're going to relax. The airways are going to dilate. Okay? Does that make sense? Your sympathetic nervous system is fight or flight during physical activity. Do you want your airways to relax and get bigger during physical activity? When you're running, when you're trying to fight something that wants to eat you, do you want to get more air in and out of your lungs? Of course you do. That's why it happens. All right? So that's beta 2. Beta 3 receptors. That's a fat cell. That's an adipocyte. They have beta 3 receptors. Beta 3 receptors are also like beta 1 receptors, excitatory. And so, when norepinephrine is released onto these beta 3 receptors, it's going to excite the cells of that fat tissue, the fat cell. And what it's going to do is cause lipolysis. And that's a term that we're very familiar with. What is lipolysis? What are we breaking down? The fat cell. The storage form of fat, triglycerides. We're going to break down the triglycerides. We're going to get fatty acids. What can we do with fatty acids? What can we make lots of? That's with an A. ATP. Your sympathetic nervous system is activated, causing more fat to be burned so that you can make ATP because you are running from something, you are fighting something. When you go to the gym and you work out or whatever, you activate your sympathetic nervous system and you burn fat. Now you know how to do it. You activate beta 3 receptors on fat cells. That's how it works. Okay? So that picture right there, and we're coming back to it by the way, is every single one of those words. That's what we used to do. And I just gave you a handful of examples. I could have given you literally 100, but I gave you 5 or 6. I mean, I'm excited to 6. Okay? Are we good? Yes? So now what we're going to do is, we're going to do the muscarinic receptors. Specific areas of the body where they lie and what they're going to do. So we're going to draw that. I know I kind of jumped around a little bit, but I thought this was the best way to present things. First the adrenergic receptors, and then the muscarinic receptors. So let's do that right now. So muscarinic, I'm going to draw a very similar picture here. So we're going to put the brainstem spinal cord right below the page, put a couple things to the left. left and one face to the right.
The next page.
Everything's going to come out of the brainstem node in this particular picture. So again, some things to the left, some things to the right. So right out of the brainstem, long preganglionic. Again, I'm not myelinating it because it's just wasting time. You can myelinate it if you sit there if you want. That's our digestive tract again. Your digestive tract not only has the smooth muscle, alpha-1 receptors, but those smooth muscles also have muscarinic receptors. So we're going to label those. So those are muscarinic receptors on the same smooth muscle cells. So what does this tell you? Your sympathetic nervous system controls your digestive tract, and so does your parasympathetic nervous system. Because that's a sympathetic, and this is a parasympathetic. How do you know it's a parasympathetic? Because that's the brainstem. That's the vagus nerve. So what's going to happen when acetylcholine is released onto muscarinic receptors of smooth muscle cells that line the digestive tract? They're going to get excited. So we're going to excite. We are going to constrict or contract. I don't remember what word I used in the notes. I want to be consistent. What did I use? Constrict. The complete opposite of the sympathetic nervous system, right? What's your sympathetic nervous system do? Inhibits, relaxes. Norepinephrine, when it binds to alpha-1 receptors, relaxes your digestive tract. Your parasympathetic does the complete opposite, and we're going to see that. That when one system does one thing, the other's going to do the opposite, although there's an exception to the rule, and I'll tell you what that is. Your sympathetic nervous system is what? Fight or flight? What's your parasympathetic nervous system known as? Rest? There you go, that's why. Because it controls the digestive system in a very large part. Stimulates it. That's why it's called what it is. Alright? What's next? Is heart next in the list? We go in the same order. Nope, airway. So we're going to draw another tube. Except this tube is not going to be the digestive tract. It's going to be the airways. Same airways that we drew in this picture here. Same airways that have beta-2 receptors are going to have muscarinic receptors on them. That is the smooth muscle cells. So we'll put and label that muscarinic. These muscarinic receptors, when they bind acetylcholine, when the postganglionic neuron releases acetylcholine onto them, what's going to happen to them? They're going to get excited. We're going to constrict the airways. The complete opposite of what happens with the sympathetic nervous system. Beta-2 relaxes, muscarinic causes constriction. Okay? Are we good? Two more. I'm going to draw on the other side now. I'm going to draw the heart, because your heart is also controlled by your parasympathetic nervous system. So we have our heart, we have our muscarinic receptors. When you release acetylcholine onto the heart, what's going to happen to the heart? It's going to get inhibited. Your sympathetic nervous system excites your heart via the release of norepinephrine onto beta-1 receptors. Your parasympathetic nervous system is going to inhibit the heart, how? By releasing acetylcholine onto muscarinic receptors. So we're going to inhibit. Your heart will beat slower, your heart will not beat as hard. Are we good? If one thing does one thing, if one system does one thing, the other's going to do the opposite. Except for one exception that I will share with you later. Alright? Your sympathetic nervous system is exciting the heart. How?